It's time for part 2 in our complete beginner's guide to self-hosting. My name's Alex and I'm from Tailscale. In part 1, I showed you how to install Proxmox, a hypervisor OS, onto this little Dell small form factor PC. I'll put a link to that video up here. In today's video though, I'm going to show you how to get started installing a bunch of applications. Immich to replace Google Photos, Audiobookshelf to replace Audible, and then Home Assistant to get started with self-hosted, privacy-respecting, open-source home automation. I'll also show you how to access all of those things from wherever you are in the world on your phone over 5G. You can be on holiday on the other side of the world and still connect back to this little box running under your stairs over Tailscale completely for free. So that's what we're going to do in today's video. We're going to show you how to install a bunch of applications and get started with self-hosting and Tailscale. Okay, so let's pick things up exactly where we left them a couple of weeks ago. This is a completely fresh Proxmox install. I'm connected to essentially I'm using Jet KVM here as if it's a keyboard, monitor and mouse physically plugged into the device to record the screen so I can show you on video. This is exactly the same as if you had literally those physical things on the table in front of you, except I can see it in a web browser. So you can see here, when we boot into Proxmox for the first time, we get a IP address. Now, IP address you can kind of think about a little bit analogous to like an apartment building, for example, like the address of an apartment building. And then the port number, which here is denoted by 8006, that's the apartment within the building. So you've got the apartment building of 192.168.1.10, and then the apartment or the service that we want to access within that building running on port 8006. So what we do with that information is we take this string here, and we type it into our web browser over here. So we do https://192.168.1.10:8006. We'll probably get the scary, this is an HTTPS self-signed certificate, the world is about to end error. Don't worry about that, it's fine, you can just click through. We're going to deal with how to get rid of that error in the next section, or this section, technically, I suppose. Because what we're going to do first is installing Tailscale. I've got like a little cheat sheet here, which I'll probably put this, this document into the GitHub repo. All of my videos have code snippets, or most of them have code snippets, and like a running order of what's going on. So I'm going to put this script, this document, into the GitHub repo, which will be linked in the description down below. And as best as I can manage, I'm not going to edit each chapter, because there'll be chapters in the description, so you can skip to the part of the video that you want. So to start with, we're going to talk about installing Tailscale and how to set up Tailscale SSH. Should probably talk about also setting up a TLS certificate using Serve so that we don't have to worry about a reverse proxy. So we'll come on to all that stuff later. Then we'll install Docker. We're going to partition our data disks, install Immich, right? There's a lot to do today. So it's going to be quite a long video, hence make liberal use of the chapters. Okay. So we want to get logged in now to our Proxmox installation using our username and password. I think I actually set a different password. I do actually, by the way, have a video on how to, you can probably find that up here, on how to configure Proxmox to log in using your Tailscale identity instead of a username and password. But we're in that kind of classic chicken and egg problem right now where we don't have Tailscale installed on the node, so we can't use it for like this. Also, this is a beginner's guide, and that, you know, replacing authentication is probably step 7, maybe even step 17, and we're on step 1 here. So just get logged in with the username and password and you should be all good. Now that little subscription nag there, back when I was a Proxmox junior, several years ago now, I thought that meant you had to pay for Proxmox. Don't worry, it's completely free. That little subscription nag is only there to remind you to contribute to the upstream project, should you wish to. You don't have to pay them a single penny. Now, in order to make that subscription nag and everything else like go away properly, I think I showed you this in part 1, but just a quick recap. You can go to helperscripts.com and search for post install. And then you can run this little script against your Proxmox server by taking it onto your clipboard, copying it and going to the node, clicking on shell. And this is giving you a command line interface, effectively like a remote shell to control that remote Proxmox instance. You can then copy and paste it onto the terminal and go through. So I'm going to start the install script. Yes. I'm going to correct my sources. Yep. Disabled. Yep. Enable high availability. No, this time I made a mistake in the last video, which So many of you lovely people pointed out. Do I want to update it now? No. Do I want to reboot now? No. So what I'm going to do is do an apt update. And then the next thing that Proxmox we should do, because it's been a couple of weeks since I touched this system actually, is we're going to run PVE upgrades. Typically what you would do is apt upgrade with a Debian system, which is of course what Proxmox is based on. But the Proxmox project recommend that you use PVE upgrade. There's some Proxmox specific stuff it does in the background. And you can see we're going to get a new kernel, we're going to get a whole bunch of new packages. And essentially, it's just good practice to make sure that your box is up to date before you start doing anything else. So this will take a couple of minutes. I think for the most part, I'm going to leave this video unedited, but when there's like a 2-3 minute long bit of text scrolling by, I think I'll do a cut. So see you shortly. Okay, and we're back. I went ahead and rebooted the node after the packages had all installed because we've got a new kernel. I followed that process over here in JetKVM, but now if I refresh this page, we are back and we are good to go. So what do we need to do now? We want to install Tailscale for a couple of reasons. First of all, I don't want to be managing SSH keys. Like in this directory here, you can see authorized keys. There's nothing in that file, so I'm probably jumping ahead here. What is an SSH key, Alex? Okay, so typically when you're authenticating with SSH to a remote server, there has to be some kind of way for you to prove you are who you say you are. And typically we do that either with a username and password, or we do that with something called an SSH key. This uses the PKI, the public key infrastructure, kind of concepts of Alice and Bob to make a key really easy to reverse engineer in one direction, but hard to work out in the other direction. So the public and private key pairs come together to basically prove that I am who I say I am. But that means you have to manage SSH keys, which, let's be honest, is, if you're familiar with the topic, it's kind of a pain. But with Tailscale SSH, there are no usernames, well, there are usernames, there are no passwords, there are no SSH keys or anything like that. So first of all, that's why I want to get Tailscale on here. Secondly, is I want to use Tailscale serve so that we don't have to worry about this pesky insecure message at the top here as well. And then of course, if this is a node on my Tailnet, then of course I can access any of the services running on this box from anywhere I like, such as my phone when I take a picture and have it upload to my Google Photos self-hosted clone, for example. So let's head over to tailscale.com/download, and we're going to get the Linux install script from here. I'm going to copy that onto our clipboard, go back to Proxmox and paste that in just here. This will take 10-15 seconds to install. So now we need to log in and create this node or add this node to our Tailnet. So we want to go to tailscale.com, no download this time. And in the top right hand corner, if you don't already have a Tailnet, you can click on this button, get started. It's free. There are 100 devices and 3 users for free. And we've made a commitment that this will always be free as well. So you don't need to worry about rug pulls and all that kind of stuff in the future. I already have a Tailnet, of course, might be biased, but I want to click on my admin console just here. And then you can see that actually this is a demo instance of PVE, so I'm going to delete that. But you can see I've literally only got 2 devices in my Tailnet right now. This laptop that I'm connected from, Baldric, and the other one is my gaming rig downstairs, as I like to stream video games sometimes over Tailscale using, Artemis and Moonlight Sunshine, all that stuff. I've got a video coming on that soon, so get subscribed, like, comment, subscribe, all that good stuff. So now we are logged in the browser. Let's go back to Proxmox and we're going to do tailscale up -- 2 dashes is important, SSH. This is going to give us a URL which we're going to copy onto our clipboard and paste into the browser. It's then going to ask me to authenticate to my Tailscale account, which in this case my authentication is done through Gmail. That bit's not important. Obviously, you can use whatever auth provider you like when you set up your Tailnet, but I just found Gmail the most convenient for these tutorials. And if we click now on Visit Console, you'll see that I have the PVE node is now on my Tailnet. So, time for the big reveal, so far as SSH is concerned at least. I'm now going to do SSH root at PVE, and that name, that string by the way, must match the name that is specified here. So I could do the IP address if I want to. I could do the fully qualified host name of Velociraptor-Noodlefish, or I can just do the node name itself, which is what I'm going to do here. So SSH root at PVE, no usernames, no passwords, no SSH keys, and I'm logged in to my Proxmox instance. Come on, that's pretty cool. So now we want to get rid of the self-signed TLS certificate. Now there are two ways we can do this actually. If we look in Google for Tailscale Proxmox, we have an article on Tailscale on a Proxmox host. And there are two things we can do. One of them is to enable HTTP access from the Proxmox web UI, is run this little script here. We can generate a Tailscale certificate and install it into the Proxmox, I guess, key store, certificate store. Or we can just press easy mode and use Tailscale serve. So guess what I'm going to do? I'm going to do easy mode. I'm going to do sudo Tailscale serve, go back to my instance, copy that and put that on the clipboard. Sudo is not found. Well, I'm root anyway, so it doesn't matter. Sudo, by the way, elevates your privileges. If you're not familiar with what sudo does, it takes you from being like a standard user, so like Alex, and turns you into a super user do. So sudo, sudo. But now you can see that I have a new node on my Tailnet that I can actually access with a TLS certificate. So if I have this domain name here of PVE Velociraptor, if I copy that onto my clipboard, now this will take 10, 15, 20 seconds the first time, because Tailscale now on the back end is reaching out to a certificate provider called Let's Encrypt, which is completely free, and generating you a TLS or an HTTPS certificate, an encryption certificate. And there you go. In real time, there were no cuts or edits there. You can see that I'm now accessing my Proxmox installation over Tailscale with a certificate. Now, a couple of important things I want to point out. This address is only available within your Tailnet. Tailscale also offer a product called Tailscale Serve. I say product, it makes it sound like it costs money. It doesn't, it's free, it's on the free tier. But Tailscale Funnel does the exact same thing as Serve, except it makes it available on the public internet. Now, please don't go and put your Proxmox server on the public internet. It's just not a good idea for many, many reasons. Just don't do it. But if you have an application you want to share with friends and family who aren't using Tailscale for some reason, or you want to share a prototype of a website you're working on or a project you have hosted locally with somebody from your laptop or whatever, Tailscale Funnel is designed and works really well for that use case. It's not very well suited to long-running use cases like hosting stuff like a Proxmox interface or something like that. So anyway, back to the point. Tailscale Serve makes this interface of the Proxmox UI available within your Tailnet. So now, anywhere you are connected to Tailscale, you can also now connect to your Proxmox instance using this fully qualified domain name. Now, I use that phrase quite a lot. You might see FQDN in a lot of stuff. That's what it means. The fully qualified domain name here of velociraptor-noodlefish.ts.net. That's the fully qualified domain name. Now, a couple of things I didn't mention, which I probably should do before we get off this topic. Under DNS, you've got to make sure that you have a Tailnet name. So by default, out of the box, all Tailnets come with this kind of like placeholder name. It's not memorable. It's a little bit ugly, but you get it for free. You also get a real name for free of something with a tail and something with scales if you roll the dice and come up with a unique name for your Tailnet too. So go ahead and make that change there. In order to actually utilize the DNS name and the HTTPS certificates as well, on a fresh Tailnet at least, you'll need to make sure that Magic DNS is turned on and the HTTPS certificates are turned on as well. So with that done, that's the basics of configuring Tailscale on Proxmox. The next thing we want to do is go ahead and install Docker. So I'm going to go over to get.docker.com and just copy the first little bit of this script right here. I'm not going to worry about the O install Docker part. I'm going to paste that into my clipboard, do a pipe to SH, and this is going to install Docker on my Proxmox host. Now, Docker, you've probably heard of this. It's a containerization engine that lets you run containerized applications on Proxmox. Now, there are a lot of different schools of thought, shall I say, as to whether you should install things directly on the Proxmox host or create virtual machines and put things in virtual machines, or create what are called LXC containers or LX containers, because the C already means containers. Anyway, to be honest with you though, this is a beginner's guide, okay? And I want to keep things as simple as I can, whilst also giving you just enough breadcrumbs to follow for you to start playing with that stuff moving forward. So for today, we're going to put everything on the Proxmox host itself. We're not going to do any VMs. We're not going to do any LXCs. But what we are going to do is we are going to use Docker Compose to declaratively declare what all of our containers look like on the Proxmox host with a text file. So with Docker install, we're going to do docker run --rm it hello world, just to prove that Docker is actually working, and hello from Docker. This message shows that your installation appears to be working correctly. Hooray! Okay, so I'm looking at my little list here. The only thing we've got left to do now is partition our disk. So how do we do that? Our data disk. Now remember when I showed you in part 1 the hardware for this thing, there are 2 disks in this system. The first one is a NVMe SSD. So that's this one up here. And this is a Samsung 980 500GB NVMe SSD. This is where Proxmox is installed to. This is where your Docker containers will be running, but we want to make sure that their data persists somewhere else such that we can back it up later. And again, this is a beginner's guide. We will probably come on to backups in a future part, although I'm not promising anything to be part of this series. I think a dedicated video on data backups over Tailscale is probably warranted. But what we want to do is create a partition on this disk here of SDA, our SATA SSD, and create a file system on it. So remember that little phrase there, SDA. Now, you don't want to really rely on those identifiers to reliably exist to identify your disks. If, and in our case, this won't happen in this little Dell box, but let's say you build a server with 4, 5, 6, 7, 8 different SSDs in it, and you sort of move them around, it's possible that on each reboot, those devices can enumerate with different namings. So if you start putting config files together based on SDA, it can sometimes happen that that name will change and then the config file is invalid. What we want to do is, well, first of all, we need to create the partitions, and then we'll come on to how to actually access the data that's stored on those disks. But first of all, now this is, you've got to be careful with this next command, okay? We're going to use wipefs, and I'm going to put in dev SDA. Be warned, this will delete all the data on your disks. You can see here that I have, on SDA itself, I have 3 different entries, and then under SDA1, which is the first partition on this disk, I have 1 ext4 partition. ext4 refers to the name of the file system. So you know that binder you used to carry to school every day that had like different plastic wallets in it? You can kind of think of those wallets as like partitions almost. So you've got the big binder, which is the disk, and then inside the binder are the different plastic wallets. And typically, when you're doing a data disk like this, you probably just want one giant partition, which is what we have here. But I'm going to create it for you on the stream, on the video at least, in real time. But when you're using a used disk, or even sometimes when you buy a brand new disk, they come pre-formatted with NTFS, or like you just don't know what's happened to them before. So it's probably a good idea, although please exercise caution. Double check the commands you're about to run in this next section because they are destructive. So I'm going to go ahead and just do a wipefs -a on SDA1 and then SDA. And this is going to remove all of those different signatures that we had on the disk. And again, if I do wipefs without any commands, you can see that nothing exists on the disk now. It's completely empty. So if there was data stored on that disk, it's now, unless you send it to drive savers or something, it's now gone. So please double check before you run wipefs on a disk, exercise some caution, and don't just run it willy-nilly. Okay, now we want to create a partition next. So I'm going to do gdisk, which is the application I'm going to use to create a GPT partition table. I'm going to press O for a new, GPT MBR. I'm going to select yes, and then I'm going to create a new partition. Remember, we're just creating the plastic wallet at this point that everything lives within. We're not actually creating the file system yet, which is, how do you explain that? Okay, so you've got the binder, then you've got the plastic wallet, and then within inside the wallet is the file system, is the contents, I suppose, is the best way to think of it. And then I'm going to do right here. So we now have one partition on this disk, and we can look at that by doing fdisk -l dev SDA. You can see that SDA1 now exists. So I mentioned a moment ago that we don't really want to refer to that SDA moniker unless we absolutely have to. So what do we do instead? Well, if we go to dev disk by ID, we actually get a list of all the disks connected to the system with their constituent serial numbers. Okay, so this means that this is a unique identifier for the disk, much in the same way that dev SDA is. And you can see it's actually just a symlink anyway. So really, for me, this is the best way to refer to disks in your system. So what we want to do now is create that file system using the ATA SPCC blah blah blah, right? So by the way, if you want to clear your screen, you can do a Control L. You can also type clear, but I always prefer Control L. So just a free tip for you there. Now we want to edit a file called fstab. So we're going to use Vim to do that. So type vi, edit the fstab. You can use nano as well if you would prefer. Now, when I open Vim, I'll try and talk you through the keystrokes because I really love Vim. It's one of those editors that once you start using it, and I've been using it now for maybe 7, 8, 9 years, there is a hurdle to get there, but I promise you, it's worth it. All right, so you open Vim, you do a Shift G, that takes you to the bottom of the file. You now press O, and this puts you on the next line, but it also puts you into insert mode, which means you can actually type stuff, because that's something that often confuses newbies with Vim. So we're going to do /dev /disk /by-id, and then put in the name of our partition. We are now going to do mount SSD. So this is where we're going to mount the data directory to. We are then going to mention the file system type that we are using. So in this case, I want to keep things incredibly simple, excruciatingly simple for this video. We could use ZFS here. We could use ButterFS or Bcachefs. But each of those things are what are called copy on write file systems. They can do things like snapshots and replication, and they have a huge amount of features. But again, like that's step 73 and we're on step 1 or step 2 here. So I want to keep it really simple with ext4. It's a really old, tried and trusted and true file system on Linux. If you want to use something else at this point, please go ahead and do that. I won't come and mark your homework down for doing it. But if you're just following along, ext4 will do you just fine for now. Next, we want to put in defaults, no A time, and discard. Some basic stuff here for the fstab file. And then we are done. So to exit insert mode, we press escape. And then we do :write, :w, and then quit. And now that file has been modified. So if we do fstab, we can see here that the edits we made have been persisted, I guess. Now we want to create the file system on this disk. I don't think I did that, did I? So we want to do makefs mkfs.ext4 and then put in the partition that we want to put ext4 onto. That's now created the ext4 partition on the disk for us. The last thing we have to do is create the mount point. This is where the disk is actually going to be mounted by Proxmox. Actually, I'm going to create mount SSD1 because who knows, maybe we add another SSD later. And then that means I've got to edit my fstab again. So I know I want to look for the phrase SSD. So if I press /SSD, it'll take me right to the part of the file I want to go to. And then I can do insert 1. So insert, it means letter I, type the number 1, press escape, press : write, quit. And trust me, this stuff becomes muscle memory after a while. If you've been looking for a way to start Vim Tutor is a really good way to do it. Stick that into Google. You'll probably lose an evening to it, but you're welcome. All right, so we now have fstab created. We have the file system on the disk, and I think we're good to go. So let's do mount A. Yes, we need to do systemctl daemon reload to pick up the new fstab file that we just created. Mount -a, and we can type mount again, and we can see that this disk is now mounted on our system. One last tip, here's a new app that I just found that I absolutely adore. It's called DUF. It just prints you out a really nice, easy to read, like overview of all the different things on your system. There's a bunch of other stuff you can do with it if you do --help. We won't get into that for today. So I think if I look back at my original running sheet, we've done all of the Proxmox setup piece now, which means the next chapter is going to be installing Immich. Next up, it's time to install Immich, the self-hosted Google Photos clone. And you can find them over at immich.app. Now, they have a wonderful getting started section on their website, but we're going to do things slightly differently. For example, they recommend that you use an end file with your Docker Compose file. There's a couple of things I'm not going to do the way they recommend. I just prefer to keep things fully declarative and have everything in just one single file. So, link in the description is a copy of this file. And the reason I modified it slightly is for a few reasons. First of all, we want to put Immich on our Tailnet. So we're going to do that using this sidecar method. And this effectively creates, so you've got the Immich application server over here, and then you've got the Immich Tailscale connection server. We kind of merge those two things together. We've done this many times on the channel now. You kind of merge these two things together using this network mode command here. And it basically puts Immich directly onto your Tailnet, so you can access it from anywhere in the world using Tailscale Serve with no reverse proxy configuration required. So in the description down below will be this file, the whole thing. There's several containers in here. You've got the Immich TS container, first of all. You've then got the Immich application server container. And these paths, we'll come onto these in just a minute, don't worry. You've also got the Immich machine learning container. This one's pretty interesting, and I have a video linked up here where you can look at how to do remote GPU machine learning for Immich. So if you're importing 100,000 images or something, you could have an NVIDIA GPU in your gaming rig actually do all of the processing and machine learning and face recognition for Immich and spare the poor CPU of your little Dell box or something like that. We're just going to run this all in CPU mode today and all in one place. But if you did want to do remote learning, like I say, there's a link to a video I've already done about that. Now, Redis is a piece of software that essentially just acts like a sponge. When you're adding all of those pictures, it's not necessarily the case that Immich can soak up all of that pressure all at once. So Redis kind of just acts like a buffer, if you like. It pulls in all the stuff and kind of queues it up and stores it temporarily until Immich can actually get to processing it later on. So it's a queuing piece of software. So if you've ever wondered what Redis does, that's what it does. And then you've got the database, of course, which is a very important piece of software using Postgres in this case. Now, the way that Docker works, we're going to need to do something with what are called volumes. These are a way to persist data outside of the container runtime environment, such that when you destroy and recreate the Docker containers, all of your databases, all of your pictures and everything remain intact, which is obviously what we want. So we've got to make sure that some of these paths exist. Now, on our Dell box, we already know that this path exists of mount SSD1 as defined here. But if this data path doesn't exist, Docker will go ahead and try and create it. However, further up in our Immich TS thing, we need to create these paths here because we've got to put a couple of config files in there in order to configure the Tailscale container. So let's go ahead and create those paths. I've just copied that path onto my clipboard. Again, via SSH, I'm going to do make dir -p. It's going to create this whole folder path for us of mount SSD1 app data Immich TS config. I'm also going to do the same thing with TS state. By the way, if you want to delete the whole string, you can do a Control W, and that will delete the entire word behind the cursor. And then on Immich server, we also want to make sure that we have this directory actually exists. It may already contain data in your case. You know, you might already have a directory with folders in it, but I don't think we do here, do we? No, data does not exist. So we don't have to create this in this case because, like I say, Immich would go ahead and automatically create it for us, but it can't hurt to create these directories. Now, I don't think I have this app installed, so I'm going to install it right away. Tree is an application that lets you list out directory structures. Okay, so you can see here that we've now created a few different directories. We've got app data, Immich, TS config, TS state. We've got data, photos, upload, and this is just reflecting what's in our Docker Compose file. Now, in terms of what we need to do, we need to put a few files in a few places. So let's create in here, we've got app data Immich. So in that folder, let's go to here to app data Immich. We're going to create a new file called compose.yaml, but we're going to do that from VS Code. Now, if you didn't know, Tailscale make a VS Code extension. So you can go to the extensions option over here, search for Tailscale, and install that directly into your VS Code editor. The benefit of this is you can now click on this little Tailscale button, and you can see all of the nodes in your Tailnet. Now, okay, I've only got a couple, but we want to do things like change the SSH username. I'm going to change mine to root, and then I'm going to change the path. I'm going to right click and then change root directory to root. I think by default it's the home directory of the root user, but I want access to the entire system. And now if I click this little caret icon next to this and expand, you can see I've got access to the entire file system of this remote node over Tailscale. Remember, we haven't done any usernames or passwords or SSH keys or anything like that to kind of verify identity. All we've done is installed Tailscale in both places and logged in, and it handles the rest. It really is magic. Okay, so under MNT SSD1, we can see the same data structure that we just created in the command line. And this is useful for us today because we need to put a few files in place. So I need to rename that to Immich. And by the way, this file is of course linked in the Git repo in the description down below. But under here, we've got a couple of files to move around. So I need to copy this immich.json file. I'm going to just copy this onto my clipboard and then go over to the Tailscale extension. And in tsconfig, I'm going to create a new file by right-clicking, new file, and call it immich.json. So I'm just going to copy the contents of that into my immich.json file on the remote server now. Okay, so we've got our reverse proxy configuration here done. So this is going to handle configuring Tailscale serve for us programmatically as part of the container deployment. We also need to make sure that we've got our auth key. So over at tailscale.com, can generate ourselves an auth key by going to our admin console, settings, keys, and then generate an auth key. And I'm going to call this one Immich test. I'm going to make it reusable because I'm doing a demo and I'll probably tear things up and down a few times. You can leave this completely by default if you would like to. I'm now going to copy my auth key into my Docker Compose file, just replacing this TS auth key bit here. And now I'm going to take this entire Compose file and I'm going to put it into this Immich directory right here. So I'm going to click on new file, compose.yaml. I'm going to open that, paste, and now we are good to go. So if I do a control backtick, that's going to bring me up the built-in terminal. Or if I want to open a terminal via Tailscale in the exact directory that I want to be in, I can just click on this little button here in the extension, and it takes me right to where I want to be. Isn't that cool? Okay, so for the purposes of video, I'm going to make things slightly bigger and just have things here. Okay, so we have our compose file. Again, I'm going to run tree. We have our compose file. I think everything's set up in there. We have our JSON Immich file too. It's time we started things up. So let's do a Docker Compose pull. This is going to pull all of the images that we need to run Immich locally, which in my case took about 45 seconds. I'm now going to do Docker Compose up -d, and then just to view the logs and double check about everything's going on and configured correctly, I'm going to do Docker Compose logs -f. And all being well, this is going to do several things. It's going to spin up the database, it's going to spin up Immich, it's going to add Immich to my Tailnet, and hopefully everything will just work. Hopefully I've sacrificed enough to the demo gods today. Okay, first things first, we're off to a good start. The Immich container has automatically added itself to my Tailnet. So I'm going to copy this URL here. And if everything worked correctly, it's now going to go away in the background and start generating a certificate for immich.velociraptor. Again, this can take a minute or two, just like the Proxmox one did. It's generating the certificate, requesting the certificate, and voila, we're done. We've deployed Immich. Now, I get a lot of feedback from people saying that we need a UI for Docker. We need a UI to manage our containers. And I do appreciate that by the time you have to drop to the terminal, you've already lost a good portion of your audience. But the reality of self-hosting, at least in 2025 at least, is that you do still have to roll your sleeves up and get a little bit dirty. However, it's a lot easier than it used to be. We just simply deployed 2 files, 2 YAML files, and I think that's probably within the realm of most people's ability to just deploy 2 files. We've got the compose YAML and the Immich JSON, and that's it. Reverse proxy is taken care of. It's on our Tailnet, and we can access this now from anywhere in the world. So let's just have a very quick poke around within Immich. Let's click on Get Started. Admin email. Yeah. Okay. Right. I'm just going to skip past this stuff because I don't think we really need to worry about it. And the storage template thing, I see stability issues here. I'm just going to ignore it. I'm going to leave it disabled. I don't want my photos to be unstable. I also added a few photos from my personal collection here just so we can see what's going on. And I want to show you in real time. Actually, I don't think I have HTOP installed. Let's be fast. I want to show you just how much CPU Immich is actually using. So you can see that just for a few seconds there, it was using all 4 CPU cores to 100%. That's because in the background, Immich is doing a whole bunch of machine learning on these images to detect what's in them. So I know that all happened very fast, but let's just do something like search for the word road. Immich is now using its machine learning capabilities to look for anything in the images that looks like a road. Or indeed, let's go for train. I know some of these are really easy and basic, but you can start doing things like, what should we do? Tree sunset. And you can start concatenating these things together, and Immich will go and find, look at this. This is not even clearly sunset. You've just got a little bit of golden light on a mountain in Yosemite. And it works out what's going on. Like obviously this bison picture at sunset is clearly sunset, but I just think it's absolutely phenomenal. And we're doing all of this without a GPU. Now, admittedly, there are only 15 images. You can imagine if you start putting 100,000 images through this thing, it's going to start crying and being like, oh, just where the GPU comes in. But like I say, there's a video about that up here. So a couple of things to pay attention to in the settings of Immich. You can see there's lots of stuff going on here. An interesting one for Tailscale users might be the partner sharing feature. Now you're going to need to go into your Immich settings, create a new account, and then add a partner. And you can see that, let's actually do that in real time so I can show you. Show, don't tell, Alex. That's what you need to do. So let's just do test at test.com, ABC123. Let's see if it lets me do that one. Test. Okay, let's create that user. Cool. Yes, test. Yeah, fine. Let's go to account settings and create the partner sharing option. This is neat because it lets you effectively share all your photos and videos with those with your partner. So you can have 2 people access this Immich instance because the lead developer of Immich, a chap also called Alex, excellent name by the way, he just wanted a way to share his photos with his wife. Immich began as a way for this guy to scratch his own itch to replace Google Photos, and it's developed into this absolutely glorious project that we have in front of us now. And that's really it. There's a lot more I could dig into with Immich. I'm not going to in the interests of time today, because next up on our agenda is installing our audiobook app. Now, I promised you an introduction to the wonderful world of self-hosting, and so far we've looked at how to replace Google Photos with Immich, and now we're going to look at how to replace Audible with Audiobookshelf. The ecosystem of applications is constantly growing, and in fact there's a whole list over at Awesome Self-Hosted on GitHub, where if you want to find out more software to host, there's a huge list on here. So if I type in Audiobookshelf, for example, there it is, under media streaming, audio streaming. There's a bunch of stuff here, stuff that will let you replace things like Spotify with Navidrome, and there's all sorts of stuff. But today we're going to focus on Audiobookshelf. And much like we did with Immich, linked in the description down below is this Docker Compose YAML file. I'm going to copy my TS auth key from my Immich deployment into my Audiobookshelf YAML file. Now, something I didn't point out in the Immich section is this hostname variable here. This is the name that the container, or therefore the service, will get when it joins your Tailnet. So we've got to make sure that that name is something that you want. And then also you've got to make sure that this network mode line is present here. So service, and then this name here of service must match the name of this key, I suppose, in the YAML file right here. So the syntax needs to look a little bit like this. You need network mode service : Immich audio Audiobookshelf, and then everything will just work just fine, because we're not exposing. So one of the concepts of containers that we didn't get into yet is how it's an encapsulated thing. Nothing's allowed in or out unless you explicitly define it. So right here, we're explicitly defining that this container is allowed to reach out onto the host system and look for audiobooks, for example, on Mount SSD1 app data. Now, we also want to modify this file path to be SSD1 media, for example, audiobooks. So you can modify these paths to your heart's content. I don't really mind where you store anything, but the general idea in this scenario, at least, is that we're storing the actual data on the second SSD. It's called SSD1 confusingly here, but not the primary boot SSD for Proxmox. We're storing that on like our data drive. We store that there for just a separation of concerns, really. So much like we did with Immich, I'm just going to copy this file now using the Tailscale extension, and then in here I'm going to create my compose file. Now you could put this stuff in the same compose file as you did with Immich. Really is personal preference as to how you organize things. You can have one giant compose file, and certainly many people do, myself included, on my server, so that I don't have to keep changing directories to get the correct context into my Docker commands. But I think for the simplicity of a beginner tutorial, having that switching of context between different applications might actually be helpful. Okay, so we need to make sure, like we did in part 1 with the Immich container, that this path actually exists. So I'm going to change to my terminal here and do the make dir -p again, just to make sure that Audiobookshelf TS config actually exists. Then back in my VS Code window, I'm going to click this little refresh button up here, and you'll see that TS config has now been created. So what I need to do here is copy across again my reverse proxy configuration. Now, Audiobookshelf by default runs on port 80, so you can see I've got port 80 configured here. And that's really the only thing you need to change between different applications. This audiobookshelf.json looks exactly the same as immich.json, look, except for the port number. Okay, so let's get the audiobookshelf.json copied over. New file, audiobookshelf.json. Let's open that, paste that in. And so now we should be good to go. So I'm going to change out of the Immich directory by doing cd ... to go up a level. You can see I'm now in Mount SSD1 app data. And just to give you a lay of the land, I'm going to do L2 to list 2 levels deep in the directories. So you can see we've got the Audiobookshelf directory with a compose file, and we've got the Immich directory with a compose file. Immich is still running in the background, by the way. If I do a docker ps-a, you can see that Immich is still there running in the background. But we want to do Audiobookshelf now. So I'm going to change into the Audiobookshelf directory, do a docker compose pull. It's going to do the same thing again. Now you'll notice that the Immich Audiobookshelf container, in fact, I've just spotted an egregious mistake. You can tell I copied and pasted this, can't you? I need to change this from Immich Audiobookshelf to Audiobookshelf TS. And then, of course, how did I not spot that when I was talking to you a minute ago? You're probably screaming at the screen going, Alex! Anyway, it's done now. It's fixed. It's okay. We didn't actually create anything. So let's go back, paste that into our remote node, and save the file. And so now, when we do a docker compose pull, it has already pulled the images. We're good to go. So we've got the Audiobookshelf app and then app -ts. So if we do a docker compose up again, -d, it's going to create those applications for us. And then again, we do a logs -f just to double check that everything's going on and working for us just fine beneath the covers. So let's go back to our Tailscale admin console and just verify that that node has been added and created. And you can see we've now got an audiobooks node on here. So I'm going to copy that to my clipboard and paste that in here. And all being well, we're going to now go out to Let's Encrypt and request a certificate with our Acme account. This will take just a moment or two. And voila, we now have our audiobook server on our Tailnet. So I'm going to create my username here, again of Zaphod. Just create a random junk username and password and click submit. Okay, let's get logged in with Zaphod. So now it's time to create our first library. Now, let's look back at the Docker Compose file and kind of explain the anatomy a little bit of a Docker Compose creation command. There are several volumes defined here, and it might be confusing if you've never seen this before as to what's going on. This is the path that actually exists on the physical Dell host, not inside the container. So you can think of this thing before the colon as being the external point of data where it exists on the host. You then want to think about after the colon here of /audiobooks being inside the container. And indeed, we can see that now. If we go to add your first library, I'm just going to call this one audiobooks, and I click on browse for folder, you can see that audiobooks exists inside the container /audiobooks. If I click select folder path and create, we've now got an empty library. And if I click on the scan button, it's now going to scan for books inside that library. And we can see that George Orwell, Animal Farm, indeed now exists.
Animal Farm by George Orwell.
Fantastic. Okay. So what we haven't done yet is we haven't connected up our phone to either Immich or Audiobookshelf. And I think that's a really important part of this entire solution. So I'm going to put this under a new chapter down below. So I'll be right back. So one of the entire points of this tutorial series is to show you that with self-hosting and Tailscale, you can access your self-hosted services from anywhere. No firewalls, no complicated configuration or anything like that. So it's time to grab your phone and go to the App Store of your choice. We have apps for iOS, for Android, and many other platforms too. I'm just going to search for Tailscale in the App Store here and download it to my phone. Whilst I'm here, I'm also going to search for the Immich app and download that one too, along with an app called Plapper. There are several different audiobook clients for Audiobookshelf for iOS. Plapper's one, Shelf Player is another one. You can see that one just a little bit below it. I think there might also be an Audiobookshelf app, but I think it's only in test flight mode. So let's just double check that. Yeah, I've definitely seen it at some point, but I think it's only available in test flight, and honestly, it could use some more work. But if you're on Android, the official Audiobookshelf app actually works pretty well. So we've got Plapper. Where do these names come from? Going to put that on my home screen. I'm going to get Immich and put that on my home screen. And then also Tailscale too. So I'm going to go ahead and connect this device to my Tailnet in order that I can access these different services remotely. I'm going to go through and click all of the sort of entry wizard. I'm going to install VPN configuration. Yes, it's going to ask me for my passcode. And then it wants to get logged in. Now, I'm going to use my Google account, the same account that I logged in with my laptop. And I've just logged these two different services in as well, of tailandscales@gmail.com, and then connect this device to my Tailnet. So you will see now on the screen, look, I've got Immich, I've got audiobooks, and if I wanted to, I could just access these things in the browser. I could literally go to Safari and put this in here, and it will just work. But Immich has some nice features when you get to iOS, like automatic backup of pictures you take and things like that. So let's use the application. I'm going to install or allow notifications, paste in the URL for Immich here into the client, get logged in with, what did I put, a tailandscales@gmail.com, and then I'm going to allow it full access to my photos. So this icon up here in the top right allows me to back up pictures that I take. So let's click on recents, and for example, and now if I click start backup, it's going to start uploading things from this phone, like screen recordings and all sorts of other stuff. You can see that photos I took on this phone are now automatically uploaded. In fact, let's take one in real time and see sort of what happens. Here we go. Bink. All right. So going back to the Immich application, I'm just going to quit this thing and reopen it and do I think you can start a manual backup each time, or you can have it automatically back up photos when you're charging, much like Google Photos would in the background. And there you go. There's the picture I just took. So in real time, you know, I've been able to, you can see I'm cheating using Claude down the bottom there, look for some commands. But you can see really just how easy it is to replace some of the hosted services. So for example, Immich now is pretty much in a position to completely replace Google Photos for me. All right, so that's Immich. What about audiobooks? Now we want to put in the fully qualified domain name for Audiobookshelf. And to save me a bunch of typing on the phone, I'm going to go back to the Tailscale app, copy the magic DNS name, and put that into the Audiobookshelf piece right here. What username? I think I set Zaphod, didn't I? Let's do Zaphod, and then just the username and password this way. On all being well, I should now be able to see my Animal Farm audiobook. Great, logged in now. So I'm going to click on the audiobooks and just like that, I'm able to listen to
Animal Farm.
Animal Farm by George Orwell, narrated by Stephen Fry. And then I can download the books. Okay, I didn't know this, but there is a small fee to unlock features like downloading audiobooks for offline listening, all that kind of stuff. Supporting the developer, I have no problem with that. But you can generally get the idea here that this is a way to replace Audible. Okay, so we've replaced Google Photos, we've replaced Audible, and they're both now on my phone. So, you know, two services that are really very, very useful in my life I've now replaced with self-hosting. Now, what about home automation? We can come on to Home Assistant next. You see this one up here? This is hiding. It's ready, but we need to actually deploy Home Assistant. This is a bit different how we do this one. We're not going to do this with a container. We're going to do this using the helper scripts from helperscripts.com on top of Proxmox. Home Assistant is one of those projects that if you haven't heard of it, you absolutely should give it a look. I'm sure at some point you've gone to Best Buy or something like that and bought a smart product like a Hue light bulb or some kind of internet connected thing. And then each of those things comes with their own app. And so you end up having 15 different apps on your phone, one to open your garage door and one to turn the lights on. And it's just a mess. Well, Home Assistant pulls all of those different ecosystems together into one place and puts it, it's a local control with privacy first smart home system. The really cool thing about that is you can then have those disparate ecosystems triggering each other. So when you turn on the light bulb in the kitchen, for example, you could have it turn on or close your smart shade in your bedroom if you want to. I don't know why you would do that specific example, but it can be really useful to have all these different things be able to trigger each other. So let's dig into how we actually go ahead and deploy Home Assistant now in this epic beginner's guide to self-hosting video. So I'm going to go back to my old friends over at Helper Scripts and I'm going to search for Home Assistant. We're going to deploy Home Assistant OS as a VM, and then I'm just going to copy this string here, this how to install option here. I'm going to go back to my Proxmox box and then just copy and paste this into the shell. This is going to take us through a little wizard, and rather than creating Home Assistant as a container or anything else like that, we're going to do it as a VM because Home Assistant OS is this fully encapsulated thing for Home Assistant. It contains all of the dependencies and it's its own kind of little world for Home Assistant. Yeah, it's just the easiest way to go, I think, particularly for beginners. So let's go through the wizard and we're going to go through the advanced options just to see what's open to us. Stable version, yes, that sounds good. Virtual machine ID, 100 would probably be fine, but I'm going to set 333, just I don't actually know why. i440X, right through cache, yeah, fine. Oh, host name, I'm going to set to Home Assistant. And then we're going to do host CPU, yeah, that's fine. Our little Dell box has 4 CPU cores, so I'm going to set that. For RAM, I'm going to do 8192 for 8 gigabytes. VM bridge 0 is fine. The MAC address is fine. The VLAN is fine. The MTU is also fine. Start VM when completed, yes. And ready to create, yes. So now the script's going to go through and create the virtual machine for us. We're going to do a couple of things once it's created. We're going to attach it to our Tailnet and then also install a certificate so that you can access it from your phone, of course. That's been the theme of this video, I know, but we've done it with containers thus far. And one of the reasons I wanted to show Home Assistant here is because, well, first of all, it's a really cool application. It's one of those ones that make you feel like you're solving real problems in the real world with self-hosted software. And for me, that's where, when you start connecting those real problems with real solutions, that's where the magic of self-hosting really starts to come alive. So we can see here that the VM has now been created. It's going to boot up for the very first time. Let's wait and see what IP address we get. You can see, by the way, that a virtual machine is basically just emulating a small computer within inside your little Dell box. So it's emulating memory, it's emulating a processor stack, a disk stack, it's pretending it's got a real screen, a real SCSI controller, all this stuff. It doesn't actually matter. But if you want to view the console of the output of that machine, you go to you select the virtual machine in the Proxmox web interface, which, by the way, why am I not on my little PVE? Alex. Here we go. I should be using my little PVE thing with Tailscale Serve, shouldn't I? All right, so let's go Home Assistant console, and we've got now an IP address of 192.168.1.118, and then Home Assistant runs on port 8123. This initial setup can take a minute or two. It's doing things like expanding the disk, downloading any containers, and just instantiating itself, just creating itself, getting itself ready to go. So when that's complete, we'll be back in a minute. Okay, the initial installation is complete. I'm now going to create my smart home, Tailscale Towers. Sure, why not? Username of Zaphod. Let's just create a random junk username and password. Create account. Fantastic. Location doesn't really matter. In this example, you can of course go ahead and configure this however you would like. But you can see already this is one of the absolute magical things about Home Assistant. It's already detected all of these different compatible devices on my network. So my Android TV, my Apple TVs, Ecobee thermostats. It's just amazing. Absolutely amazing. And out of the box, it gives you a very best approximation of like a dashboard you might want. Like I can already control the light that's up here, for example, as part of my filming setup directly from Home Assistant with no additional configuration. How cool is that? All right. Enough fanboying out of the way with Home Assistant. It's time to actually get this thing on our Tailnet. So let's go down to settings. Let's crack on and install an add-on or two. First of all, we're going to want to install the Tailscale add-on. So just a case of clicking install here. And then we're also going to want to install the Studio Code Server add-on. And this will become clear in just a moment as to why we want to do that too. Okay, so let's go back to settings and add-ons once more, and we're going to start up the Tailscale container. I say container, add-on. It is really just a container under the hood. It's all just Docker masquerading. But now there is an option, and in fact I did a tutorial, which I'll put a link to up here, about you can click on Open Web UI and get logged into Tailnet. But for me, for some reason, it's not working. So to get around this, we can go into the logs of the container and click on this little URL here and authenticate to our Tailnet that way. So little workaround. I'm not sure why it's not working. I'll file a bug for that internally, and hopefully we get that fixed by the time this video comes out. So I'm going to click on connect and then visit console, and you can see that my Home Assistant now exists in my Tailnet. So if I want to connect to this instance, I can do 8123, and I can now connect to Home Assistant from anywhere in the world that I'm connected to Tailscale. But you know me, I like to have full-on TLS certificates wherever possible. So this is where the Studio Code option comes in. So let's go back to the documentation section of the Tailscale community add-on, which by the way is maintained by Frank, who seems to be like the most prolific Home Assistant developer going when it comes to all the add-ons. He does the Tailscale add-on, he does the Code Studio add-on. Anyway, he's a good dude. So let's go to documentation and scroll all the way down to where it starts talking about proxy. The Home Assistant add-on calls it proxy. We call it Tailscale Serve. So those two things are the same. I don't know why it's called proxy in the Home Assistant add-on. C'est la vie, I guess. Okay, so we're going to copy these 4 lines onto our clipboard, and then we're going to go to our add-ons page again and start the Studio Code add-on. I'm going to click Show in Sidebar, and this will take just a minute to start up. Now we could click on Open Web UI, but I've already clicked the Show in Sidebar button, so it shows up here for all time, because it's really handy to have this little Studio Code server available as part of Home Assistant. You can see we're basically just loaded now into VS Code, but in a browser. So look for this file here, configuration.yaml, and paste in those 4 lines from your clipboard. And then because you're in a browser, some of the keyboard things don't pass through correctly. So file save manually, just to make sure that this file does actually get saved. Go to settings and then restart Home Assistant. This will take maybe 10 or 15 seconds on a completely fresh install. On a more mature install, it could take a minute or two, depending on how many add-ons you've got and that kind of thing. But once it's back up and running, you want to go back to add-ons and then Tailscale and then configuration. Click on show unused optional configurations and look for Tailscale proxy. Check the box, click save. The Tailscale add-on is going to have to restart. Yes, that's fine. Go ahead and do that. And then we want to look in the logs for all of the Acme requests for the TLS certificate. In fact, there we go. This is now available within your Tailnet on this URL right here. So all being well, Home Assistant's still restarting, of course, but the actual add-on is doing exactly what we wanted it to do. You can see we've got a full HTTPS certificate at homeassistant.velociraptor-noodlefish, and we are now good to go. Get logged in with my username and password, and voila, I can now access this from anywhere on my Tailnet. So let's do that. Let's control this light on my desk in front of me over Tailscale, over 5G. So let's turn the Wi-Fi off on my phone. Let's load up Home Assistant. In fact, I'm going to load up Tailscale once more because I hate typing. And then I'm going to go to Home Assistant, copy this URL right here, or I suppose the DNS name. I'm going to go into the Home Assistant application. I'm going to enter my address manually and paste that from my clipboard. I want HTTPS. Yes, thank you, Home Assistant. I'm going to connect to that. It's going to ask me to log in, which I will dutifully do. And now, by the way, I'm on 5G, so I'm not on the same network as this, which means I could literally be anywhere in the world. I know I've belabored that point, but Tailscale is amazing sometimes. And just simply by pressing the button on my phone over 5G with Home Assistant in what I've been filming this segment for 13 minutes. I'm sure in the edit it will be a little bit less, but we've just set up Home Assistant. And that's it. That is the magic of Tailscale right there. And the magic of self-hosting and Tailscale, I suppose, actually. So what have we done today? We have set up a Google Photos replacement. We have set up an Audible audiobooks server replacement. We have started you down the journey of open source, self-hosted, privacy-respecting home automation. And we've connected all of those things using our phone over 5G using Tailscale. We haven't configured a single firewall rule. We're not paying for any subscriptions for any of this stuff. Tailscale's completely free for home users, remember, 100 devices and 3 users for free. And a device, by the way, counts as these. So we've used 5 devices today towards our 100 device limit. But if you share Tailscale with friends and family, you can add 2 devices to that free limit every time you refer someone to Tailscale as well. So I know that was a super long, epic 2-part series on how to get started with self-hosting. If you have any questions about anything you've seen in today's video, I'll be doing some live streams over the next month or 2 where you can come and ask me questions directly, or indeed you can just leave a comment down below with a question and I'll do my best to reply, or even put that into some kind of like an Ask Tailscale like video at some point in the future. I should probably do one of those. But yeah, super long video. If you've made it to the end, thank you. Please leave a comment down below with the word bananas. And until next time, I've been Alex from Tailscale.